Good afternoon, or good morning. We're going to take a look at the Pythagorean Theorem and why it works. The Pythagorean Theorem is one of the most important mathematical theories that has been discovered. And as it may seem, Pythagoras, a famous Greek philosopher, mathematician, religious fanatic, is the one who lent his name to the famous theory. But don't be fooled. The ancient Egyptians also used the Pythagorean theorem, although they didn't call it the Pythagorean theorem because he hadn't been born yet. Now, a little word on Pythagoras. This is important. You're going to want to listen. Pythagoras was an ancient Greek famous scholar. And in ancient Greece, if you wanted to learn something, you would find someone that you wanted to follow and learn everything you could from that person. And so the people who followed Pythagoras were actually called Pythagoreans. And Pythagoras was much more than a mathematical giant. He also had some really weird beliefs about, you're fine, about the world around him. For example, did you know that Pythagoreans, the followers of Pythagoras, were not allowed to eat beans?
Because they make a fart when you fart.
True story.
A piece of your soul.
Pythagoras believed that every time you farted, you lost a piece of your soul. Can you think of some people who are more soulless than others? I bet you can right now. All right. So, Pythagoras was so famous that the Renaissance painter and also Ninja Turtle, Raphael, painted him in his famous painting called The School of Athens. See this man right here? That's Pythagoras, and these are all of his Pythagoreans trying to learn from what their master is doing. Now, we're going to talk about the Pythagorean theorem, and you have to remember that the Pythagorean theorem is speaking specifically about right triangles. Not the wrong ones, just the right ones. And the Pythagorean theorem says that a squared plus b squared is equal to c squared. Well, where do these a's, b's, and c's come from, and why does it work anyways? Well, that's what we're going to take a look at. So, if I were to draw a square, and I have this square right here, and then inside this large square, I'm going to draw a smaller square. It's the yellow square. And I'm going to draw this yellow square in such a way that each of the vertices of the square touch the edge of the large square. So what I'm going to do is I'm going to call this distance from here to here A. I don't know what this distance is because I don't know how big the square is. It doesn't matter. Now that means that this shorter distance on every edge is also going to be A.
There's no paper in the printer.
Can you fix that?
I got it.
So, well, what about the longer side? Well, the longer side we're going to call B. And that side length is going to be the same all the way around the square. Well, where does the C come from? Well, the C comes as the side length of the large square. Or sorry, the small square. So that the hypotenuse of this triangle that you see right here, and the hypotenuse is the name of the side of the triangle that is the longest. So the hypotenuse is C. So that's where A, B, and C come from. Well, now let's take a look at why does a squared plus b squared equal c squared. So I'm going to go back to this square. Now, if I wanted to find the area of this entire square, I have a couple options of figuring this out. One option is just to find the total area, right? So if I find this total area, obviously it fits perfectly. If I find the total area using base times using base and height, that will get me, the pen doesn't like to work on this project board, you get the idea. That will find the area of the whole square. But I have another option. My other option is I can add together all of the triangles and the square. And that will also give me the area of the entire square. So those are my two options. So let's take a look at what happens mathematically when we do this. All right, so we know that the base is a plus b. Is a plus b. Why? Well, we have this side length here, which is a. We have this side length here, which was b. So my whole side length is a plus b. And you'll remember from quadratics, this looks really familiar, doesn't it? Well, so using what I know about the distributive property in rainbows and smiley faces, I can distribute this out. A times a is a squared. A times b is ab. Side lengths tend to be lowercase, so I'm going to keep with that. B times a is ab again. B times b is b squared. So let's combine these similar terms. So we have no other terms similar to a squared. ab plus ab is simply 2ab, and b squared is just b squared. Well, let's take a look at this triangle right here. How do I find the area of a triangle? Well, the area of a triangle is 1/2 base times height. Well, my base is a. My height is b. So the area of this triangle is 1/2 AB. What's the area of two of the triangles? Well, that's just 1/2 AB plus 1/2 AB, so that's a total of AB. So I have four of these. 4 times 1/2 AB is simply equal to 2AB. The area of this square is c times c, or c squared. All right, well, I see common terms. I see ABs and ABs, so I'm going to subtract 2AB from both sides of this, and we get a squared plus b squared is equal to, cancels out, no way, c squared. You have just proved that the Pythagorean theorem is true. A squared plus b squared does in fact equal c squared. Now, obviously, you have to write this down in your notes. If you don't have it, you're not going to get credit. But you don't necessarily have to remember how to derive the Pythagorean theorem, as long as you remember a squared plus b squared equals c squared, and this is only applicable to right triangles. In other words, triangles that have a right angle. All right. Oh, look, it only works for a right triangle. Shocking. All right, so let's go ahead and use the Pythagorean theorem on some right triangles. Now, I will tell you right now that we have 3 right triangles. That's right, I'm fixing that right now. And we know that the Pythagorean theorem is a squared plus b squared is equal to c squared, where c has to be the hypotenuse, the longest side length. All right, so let's plug these numbers in for a squared and b squared and c squared. We know that the longest side length has no value, so I'm just going to call that c for now. Does it matter if I call 9 a or b? Well, no, because I'm just adding a and b together. And in addition, it doesn't matter which comes first. All right, so we have 9 squared plus 12 squared is equal to c squared. 9 squared is 81. Plus 12 squared, which is 144, which is equal to c squared. And here's a little note. Lots of people get caught up on the math here. You always want to keep c squared on this side. Trust me on this one. Keep the c squared there. So 81 plus 144 is going to be equal to 225. Well, what's the opposite of squaring something? Square rooting it. So the square root of c squared is simply c. The square root of 225 is 15. So this side length here is 15. Well, let's try figure 2. So in figure 2, we know, again, we're missing side length, this base right here. And so we know a squared plus b squared is equal to c squared, where c is the longest side. Well, in this problem, the longest side does have a side length, 29. So I have 21 squared plus b squared is equal to 29 squared. Well, 21 squared is 441 plus b squared is equal to, what is 29 times 29? I'm a little embarrassed to admit it. I have not memorized my square numbers up to the 29th square number, so I'm just going to go ahead and square. Oh, it's 841. I should have known that. Well, let's turn this into a train track problem. The world really is just one big train track problem. And we get, oh no way, we get 400. Square root. 400 is a square number, so we get b is equal to, not 400, 20. All right, same idea here. Well, we again have the hypotenuse at 17, so we have 17 squared, because that's my c value, is equal to 8 squared plus b squared. 17 squared is 289? I think it's 289. Hey, welcome.
Hi.
289, there you go. 8 squared is 64. We saw plus b squared. All right, so let's subtract 64. Subtract 64. And we get, let's just subtract 64 here. We get 225 again. Look at that. Oh my goodness. And then we have to take the square root, and we get 15. Sorry, my pen wasn't working. Hi, Avery. Give me a second, buddy. All right, so that is the Pythagorean theorem in a quick little nutshell. Now,
That was not quick.
it was quick. So there are some other problems that we can talk about, but I think it's best at this point that you go ahead and start working on your assignment for the day. And so please read your written instructions and follow those. Don't forget, your attendance depends on you turning in your quiz for the homework last night and turning in the exit ticket for this as well. All right, have a great weekend, and I'll see you on Monday.